Okay, back again at Database Design Arts. We're taking a look at the data science tutorial, and you too can follow along at this URL, learn.microsoft.com, enus/fabric/data-science, and the tutorial is there. Really, what this is a breakdown of several or I'm sorry, a download of several notebooks that you run each cell individually. And we're going to walk through those real quick and take a look at these four notebooks, right? Ingest the data, explore, cleanse the data, train and evaluate your model, do your predictions, and then we'll take a look at the bank churn report. And maybe we'll take a quick look into this bank churn experiment. Now, I'm going to preface this whole video by saying I am not a data scientist. I don't do data science for a living. That is not my thing. All I'm here to do is showcase some of the availability of data science as it exists inside of Microsoft Fabric. So let's take a quick look through these and go from there. So prerequisites here, it says initially it says add a lakehouse. So I added a lakehouse over here called data science. And this was empty when I first started. So again, right, a lakehouse, right, a collection of files, folders, and tables, right? No rocket science there. And Delta Lake. What is Delta Lake? So Delta Lake is as Delta tables. That are built into a data lake. And Delta is actually the default value or a default table type, and it's built on top of Parquet files, and it extends the Parquet files with a file-based transaction log, right, to provide ACID transaction capability. Really, so you can roll forward, roll back, that sort of stuff. You can look at previous versions of the data. You can do what's called time travel with uh, delta tables, and we're not going to look at that today. We'll look at that probably in the warehousing video that's coming up before too long. So anyway, I added this lake house over here because it said create a lake house. Now, this data set contains churn status for 10,000 customers, so it's really not that big, right? There isn't that much data here. And really, when you look at it, you get a customer ID, a surname, a credit score, a geography, a gender, an age, a tenure. So how long they've been with the bank, right? What their current balance is, the number of products that they have, whether they have like a credit card and savings account or that sort of stuff. And exited, right? Column exited in data set refers to the customer's abandonment. So this person has exited, right? They're already out. And the first thing it has us doing really is downloading the data set, right? And you run these cells one at a time, and this is just PySpark, right? Python, right? Not rocket science. So here we're just setting up some variables, right? The output file is going to be churn.csv. It's going to put it in files/churn. It's going to be in the lakehouse, this lakehouse default, right? So no big deal. We're importing OS, which is operating system, and requests. Now keep in mind that this particular notebook and the really all the notebooks that are part of this demo, you could use um, you could use why am I drawing a blank? You could use I'm gonna take a quick look at my own here. Um, where did it go? You could use Jupyter notebooks. That's what I was looking for. And execute the same stuff on your local machine. And instead of using a lakehouse for all of this, you could generate CSV files and then upload that last CSV file into Power BI and create your semantic model off of it so that you can use it in your Power BI report. Right? No, this isn't exclusive to Fabric, is the point. So then you run this, and really what you end up getting is you get the churn folder, you get this churn CSV, and I don't think we can open it from here. Well, we can load data. You can load data, you can copy data, right? That sort of stuff. So um, if you really wanted to, you could load this data, but we're going to look at it in the next folder or in the next uh, notebook anyway. So don't worry too much about that. So let's take a look at the next one where we're going to explore that data, right? So you complete part one where you ingest the data. No rocket science there, right? We did it. It's all good. And then you create a data frame. A data frame is an in-memory data structure that has tons and tons and tons and tons and tons of functionality available to it. And then in the open source world, they have pandas, right? Pandas is a data frame that is an open source data frame that you can again use in Jupyter Notebooks, and we use lots of that in Jupyter Notebooks when it comes to data engineering and looking through data. So, right, you want to load this data up. So let's load it up real quick. Now that we know that we have it, I'm just going to run that. It takes a second to hook up, and then it gets going as soon as that's done. So that's done, right? So we have that data. We're going to cast it to pandas, right? So we're going to create a new pandas data frame. There we go. Now we're going to import some tools and set some parameters here. So import Seaborn, which is a visualizations library, along with Matplotlib, again visualizations, right, and the ticker and everything that has to go with Matplotlib. Now NumPy, right? NumPy is Py's. I'm sorry, is Python's numbering and basic math calculations. And it's not just basic math. NumPy does a lot of powerful stuff. Pandas, right? You can look up pandas. You can Google pandas data frame, and you can look at all the different stuff that happens with that. And iter tools allows you to iterate through the rows of a panda data set. It creates an iterable. So we're going to run this real quick just to make sure that all that stuff is there, so that the next cell, now each of these cells builds on the next one. So as we go through this cell, we wait for it to complete, and yeah, that one is done. And then we're going to take a look at display, right? Display a data frame or some version of data. Now, we just wanted the summary of this. So let's take a quick look at that. And these are the columns that you if you remember those from what's going on and in the data set that came in. And what we wanted to know is how many unique values are in that, um, and is anything missing, right? Do we have missing data and that sort of stuff? So again, display and the data frame and the summary is part of that. So you could do display and data frame and not have summary, right? Because you see the default there, summary bool equals false. So its default is false. But in more open sourcey kind of stuff, we look at it from this way. We say, hey, data frame is null. Give me the sum of anything that is null across the entirety of the data frame. And again, these numbers of no rows that are null correspond with what we have up here in the summary of missing, right? So we know that life is good there, everything's great. And then I want to take a look at like the geography. I want to say, hey, is any of that, give me the number of unique values inside of geography. Well, okay. And then I could actually copy that again, come down here and just say unique. I want to know the number of, I want to know those unique values, right? What are they? So there's my unique values: France, Spain, and Germany. And that gave me an object data type that is an array. If I wanted to make sure that everything came out of this data frame that I have here, I could say, hey, print, right? The number of that number of unique values, and there's my three that just printed. And you have to do that or specify it because it really only displays the last command that is down here. So Data Wrangler. Now, Data Wrangler is this tool that I'm highlighting up here that is unique to this particular tool. I don't know of another tool now. Databricks might have some version of this. I don't know. But I can tell you that from a Data Wrangler standpoint. Now, what is Data Wrangler? It allows you to explore, cleanse, look through, make some decisions about your data and what's happening inside your data that uh, that you could fix, because that's a big part of the data engineering world, right? Is we're fixing data. Hey, this is missing. Let's do something with it. This is this value is outside of its prescribed range. Let's either bring that in or exclude that record. And you work with your business stakeholders to understand not only the data, but sometimes they look at something and go, yeah, that couldn't possibly be right. It falls way outside of the realm of normalcy for the data that we want to that we're using, or that was really possible. So how that happened, we don't know, and they don't know, and that's okay. No problems there. But this script here is the result of the data wrangler if you copy it back out, right? So if you run its automated tool that uses some versions of AI, and you come up with this. Now this says drop rows with missing data across all columns. Now, do we have anything that has missing data across all columns? Nope. So drop NA doesn't do anything. In place equal true. What does that mean? So one of the values that you're going to see all across this in place is true, meaning if normally if you just do df drop NA, that's going to cast things out to another data frame. You're going to get a fresh data frame out of that just fine, right? You get a fresh data frame, no big deal. In this particular case, they wanted to take the same data frame and alter it by dropping out anything that was have missing across those little cells, and they want to drop the duplicates if it's a row number and customer ID. So we want to make sure that row number and customer ID was unique, and they want to drop the columns row number, customer ID, and surname, right? And then in order to get a return that data frame, they're going to take that. They're going to cast a new data frame called df underscore clean through through this function that is defined here. They're going to take a copy of the original data frame and return it as data frame clean. Then we're going to take a look at the head of that. And just for grins, we'll take a look at the first 10 rows of that head, right? So here's the first 10 rows of that head. And you know that this index always starts with 0 with a pandas data frame. So that's its index value. Now, pandas data frame will index it starting at 0 and going all the way down. And you can hack and slash and slice and dice using .loc with that data frame. You can locate stuff, you can query stuff, you can look for wheres. There's all sorts of things. Just look up data frame, pandas data frame, and you'll see what I'm talking about. Anyway, now we have a credit score, we have a geography, we have a gender, we have an age, we have a tenure, right? How long they've been with the bank, whether they're exited or not, are they out? So this one's exited, that kind of thing, right? So uh, determine categorical, numerical, and target attributes. So like in the last examples I was showing you, in you're right, we had C for C in dataframe.c, right? This one has column for column. It's just a variable name in dataframe columns. If column in O, and that isn't O because I wrote this in, that's a 0, right? This is a 0 and it's searching for an O. Or data frame clean column is not unique. I'm sorry, number of unique is less than 5, and column is not in exited. So in other words, we don't want anything that has a value in exited over here, and we're gonna print those back out. And you'll see when I run this that it's going to give me that same thing. So the dependent variable name I had up here is exited because that's our dependent variable. And we have categorical variables: geography, gender, number of products, has credit card, is active member. And then the numeric variables are credit score, age, tenure, balance, and estimated salary, right? There's our numeric values. So we made sure, again, column for column in data frame.columns, if data frame clean column data type, right, is not equal to object. So that's all good. So here, the example goes on to use matplotlib. That's what we see as PLT right here. And some of it's creating subplots. So we're creating 2 rows of 3 columns, um, along with some standard figurine sizes and sorry, standard figure sizes. And they're giving it tight layout. I haven't used tight layout. I don't know it, not familiar. But when we run this, we get this particular screen. So we get credit scores between, what is that, about 580 to about 720. We get ages of about 32 to 45. We get tenure when they're not exited, right? These are people that are still active customers from 3 years to 7 years, roughly. We get balances from 0 to about 125,000, and we get estimated salaries from 50 to 150,000. So that's just a look across the data that's here, right? Because it created this box plot, and that's SNS is Seaborn, right? So Seaborn creates a box plot of the columns. We wanted that color green, so here's that color, right? And AX equals the axis. And let's see, for axis and column in zip. Now zip, I'd have to look up zip again, but zip really just brings these data sets together. That's its whole point. And then we give you it shows, it just displays the axes. This next one, distribution of exited and non-exited customers. So this one actually didn't work. And it didn't work on this particular value over here for the axis. And this count plot did not like the axis that was coming in from this ax array. That ax array is the result, is a variable that's returned by the subplots. So I don't know. I just printed off some of this stuff, and like I said, there's some things I've used in here and some things I haven't. And Seaborn count plot I have not used, so I just commented that out. Here's the subplots as they were, but they don't render properly because the data doesn't come out properly. So that's part of it. Distribution of numerical values. So let's take a look at all of um, the columns that contain numerical values and their particular distributions, right? Again, here we see the credit score, and that normalized, this is a normalized distribution. If you look at normalization, right, we'll look at age. Again, that's a bit of a normalized distribution. People's balances, that sort of stuff, for things that aren't, uh, I think they filtered out zeros. Plot dot figure set size 18 by 8. Title I. So iter tools. So that's the iterations. They're going to zip the longest. Okay. Yeah. Columns range. So that's where we're getting. That's why we're getting the non-zero values. They're coming out of that. So they're gonna they go through using DF Clean, and they create new tenure, new credit score, new age score, new balance score, and new estimated salary score. And they pass off these particular labels. Let's see, QCut, quantile based. Oh, interesting. I haven't used that one either. And there's so many things that that everything does that it's almost impossible to use them all. And then we're going to take a look at clean data. So this particular function down here creates a delta table. And if we look in tables, we're actually creating df clean, which is this uh, delta table. And we could do it and overwrite it, which is fine. Oh, did I not create df clean one? I didn't. So there's df clean one. I'll rewrite df clean. And we'll wait for that to finish. And then we'll move on to step 3, where we train and register some machine learning models. Now, I'm not going to claim to be a machine learning expert. Now, I've been dabbling in machine learning for a while now, and we did some of it at MIT, but it takes a bit of a special mind to wrap your head around some machine learning, and it's all good. As per part of the, why am I drawing a blank again? Part of the Jupyter notebooks, you can use pip to install things. So IBM Learn um, and pip install. So I'm gonna run that again, and it should just tell me that it's already installed. But essentially, pip is Python's installer for notebooks, and you can install things in particular notebooks and really and get stuff done using those particular things that you've just installed or imported. Once it's installed, you do have to actually import things. So you're going to see in just a minute where we actually have to import particular functions from IBM Learn. All right, so that's done. And again, we're importing pandas. Okay, so in this particular step, it's creating a new experiment in machine learning flow, and it's saying that's the bank churn experiment. I've run this already. I don't know if this is going to fail or succeed. Looks like that succeeded. Anyhow, so now we're gonna do some ML flow. Oh, so we're setting an auto log. We're capturing, we're setting that current experiment to the experiment name that we just created, and we're setting its logging to auto log and exclusive, which is fine. Scikit-learn, I've used some bits and pieces out of as scikit-learn, and it's actually really nice. I don't know what light GBM is, and I have not used it before. Not very familiar with light GBM, but train test split actually brings in 3 different data sets. It breaks down and helps you break down 3 different data sets. Random forest classifier, you can sort of see the explanation there. I'll pause so you can read it. And then a bunch of other stuff from metrics, right? Accuracy score, F1 score, precision score, confusion matrix. We'll talk about that. I've used the confusion matrix to some extent, but not extensive, not exclusively or in great quantity. Some of these other scoring models, I really don't know, but that's okay. That's how you get to learn, right? But again, if you don't bring all that stuff in, then you really can't pick it up. All right, so this actually brings in a y variable that is everything that's from the exited, right? Where exited is true, and then it brings in the x variable after dropping everything that is exited, which is great. So we have x train, x test, y train, y test, and again, here's train test split. So we're dropping in x, y, test size is zero point 0.2, and the random seed is our seed literal 1, 2, 3, 4, 5, which is how it breaks those that data up, right? And again, we're going to do that again for train test split x for the training data, x train, y train. So let's create our training data, and it should be there. Okay, and we just created our DF test table, and you probably saw earlier that we have data frame test right here. Just as a note, this little delta here on top of the table tells us that that's a delta table. And you can see that we're specifying the table format of delta when we're doing those writes. I am not familiar with what this is. Don't know. Not a data scientist, right? What I can tell you is that we're importing a counter, and we're importing uh, smote, smote. Let's see. Only 2,037 customers have left the bank. This indicates data set is highly imbalanced, which seems right, right? Because that's an 80-20. The problem with imbalance classification is there are too few examples of the minority class for the model to effectively learn the decision boundary. SMOTE or SMOTE is a widely used approach to synthesize new samples from the minority class. Hmm, okay. So we're gonna take that minority class, and we're gonna extrapolate or create some data. So that seems pretty data engineering standpoint. And again, we're using that random seed of 1, 2, 3, 4, 5, and fit resample. Well, fit actually makes, I can't say that. Fit in a different under a different library, the fit function does some different things to make your data fit into particular models. Right? So anyway, here's our experiment, bank churn experiment, and we had a run named Keen Stomach. I don't know why they name them the way that they do, but they do. And we're going to do some model training now. Here's where we're using sklearn. Well, this is MLflow, and I'm not totally familiar with MLflow, but I have some experience with sklearn and with scikit. If I could walk you through all of that code with 100% accuracy, I would do it, but I can't. Wish I could. But again, down here, we're creating a confusion matrix from the X and Y value, and we'll walk through what a confusion matrix looks like and what it really means. So we just created another bank churn experiment run name, random forest with maximum depth of 8 and 6 features. So we're doing the same thing again. And like I said, I am not familiar with light GBM. Don't know it. I'd have to go in and read the documents. And sometimes you just don't have time to read it all. Like I said, not a data scientist. But like GBM sample model, go. Okay, the experiment runs are automatically saved in the experiment artifact. So here's the bank churn experiment that we're talking about. On the left pane, select your workspace, find and select the experiment name in the bank, in this case, bank churn experiment. If you don't see the experiment in your workspace, refresh your browser. So that's what they're talking about right there, that bank churn experiment in my workspace. We'll go in and look at that in just a second. And then we're going to populate some more stuff inside of that bank churn experiment. True, false, positive, negatives. Again, this is Seaport, Matplotlib, NumPy, and the iterative tools. So if you just look at the data, right, here's the data as it equates. And this is our training data. So I'm sorry, our testing data. So we have the greatest portion here is non-churn. And I don't know why this is off, but random forest max depth of, I think that one is 2 to 4, and this one is 8 and 6. You can sort of see the numbers different. Again, for churn and non-churn. Like I said, I'm not a data scientist, but this is how it would work. The same exact things are available in Jupyter Notebooks. It'll look exactly this, almost exactly the same. There's a few things that aren't identical. The predictive models. Now, back at MIT, we did some predictive modeling, not a ton, but some. Right, so we've got to load up this our DF test first. Because this notebook is already hooked up. So if you get a notebook that isn't hooked up, you'll see a green button over here where you can add data items, and then you would go in and select the data lake that you're using. So, and if we wanted to say the summary was true for that, we could go in and read it again. And this time we just want the summary. Balance, geography, Spain. Now, I'm not going to pretend to be an expert with machine learning and transformation. You can run through all this yourself. If you're a data scientist, this probably means a lot more to you than it does to me, right? But it's going to output a column called predictions in the model name LGBMSM, which we created before over here in the bank churn experiment. Again, we're going to bring in pandas. And I'm hoping. All right. just going to have to know that we ran all the rest of that. And then the demo walks you through creating the semantic model inside of your Lakehouse in order to create this report, the bank customer churn. Anyway, so you can get to this by going to Fabric, right? Learn Microsoft Fabric Data Science, go to the end-to-end scenario, right? Introduction to architecture, and you'll be able to get to the end and this particular report. Good luck. Thanks.